of a function. A function is a set of code that performs some task. So what this essentially means is that you can have a number of instructions which are bundled together in a function that is given a particular name. And now using this name, you can call this function to execute these instructions from anywhere in the program, any number of times. So this is the syntax of a function. You have the keyword def, following which you have the function name and then the double colons. And then in the next line, you can put your statements or your instructions. So that is basically what a function is. We'll go through a number of demos to understand the concepts of functions. So I'll move on to PyCharm. Let's start from the very basic, that is how to create a function. Now this is called the definition of a function, and as we are creating the definition of the function, the keyword that we begin with is def, that is the short form of definition. And now following def, we have the function name. So here I'm going to have a function called welcome, and always you end your function name with parentheses. Now these parentheses may be empty or may be filled, which we'll look into later. For now, it's empty. And then we have the double colon. So I want this function to just print out good morning. So that is my instruction. And with that, my function welcome is complete. Now this function has no purpose unless it's called. And for that, we write the call statement for our function welcome. So for calling the function, just put in the function name followed by parentheses. Now let's run the code. And as you see here, our call was made to the welcome function and the instruction within it was executed. Thus we have good morning printed out here. So as I said previously, these parentheses here, these could be filled or left empty. We saw what happens when it's left empty. Now let me create another function where I'm taking in values. So sometimes the operation that a function does requires some values to be passed to it. So this is where we have parameters or arguments come in. So now I'm going to write a function called add, which will basically add two numbers. Now these two numbers need to be passed to this function. So the function does not know what these two numbers are until you literally give it the numbers. So these numbers will be stored in variables, say A and B, colon, and within this I'll have a variable, say total, which will hold the sum of A and B. And then we'll just print out the sum. And with that, our add function is also defined. Now we'll make a call to our add function. Add, and now as you see here, we are accepting two values in this add function. That means we also need to pass two values to this add function. Now suppose I want to add the numbers 10 and 20. I can go ahead and just put the numbers 10 and 20 here. Or I can have two variables, say x, which is equal to 2, and y, which is equal to 3. And then to add, I can just pass x and y. Either of these methods work fine. Now I'll run the program. So as you see here, the add function is called twice. This is our first call to the add function where we pass 10 and 20. So A holds 10 and B holds 20. So the total of this is 30, which is printed out. The sum is 30. Now after this, we have another call to our add function where we are passing x and y, x holding 2 and y holding 3. So over here, when we pass x, we are essentially passing 2, and when we pass y, we are passing 3. Now this 2 and 3 get stored in A and B respectively, and our total is again printed 2 plus 3, which is 5. Now this is one of the main advantages of using function. If I had to write this code, total equal to AB, twice to add two numbers, that would be a little lengthier procedure than having a function and just making a single line call to the function every time I want to add two numbers. Now as you notice, the values that we are passing to a function are very position dependent. That is, since I'm passing 10 first, 10 goes into my first variable A, and 20, which I'm passing second, goes into my second variable B. Now just to make sure that this is how it works, let me print out the value of A and B separately. So now let me run my program. And as you see here, since 10 was passed first, it's stored in A, and 20, which was passed second, is stored in B. Same here, 2, which was passed first, stored in A, and 3 stored in B. Now what if I don't know whether the function accepts a first or b first? Now in this particular case it does not matter because 10 plus 20 or 20 plus 10 still gives 30. But we still want to ensure that 10 does go into a and 20 does go into b. So let's say our function accepts b and then a. Now we want 10 to go into a, but we don't know that a is the second or the first argument that's accepted in the function. So this is where we have keyword arguments. So with keyword argument, what happens is that since you want 10 to go into a, you can specify here a equal to 10. And you want 20 to go into b, so specify b equal to 20. Now let's run this program. So as you see here, although the function accepts b first and then a, and we passed a first and then b, still the values that are held are correct because we said a should be 10. So 10 went into a and we specify that b should be 20, so 20 went into b. So here we are making our values that we are passing independent of the position of the arguments. So far we passed exactly the number of variables or values that the function is expecting. Now what if, although this function add is expecting 2 values, we only pass 1? I'll just remove this part here and I only pass 10. I run the program and there's an error. Now we don't want this error to happen. So even if we are passing an unknown number of variables, that is we don't know how many variables the function takes, we are just passing values. I want that something happens. It does not result in an error. So in this case what I can do is I can give all the values that I'm accepting a default value. Make this back to a comma b. So if the value a is not passed, its default value should be 0. If value b is not passed, the default value should be 0 again. So this is how I set my default values. Now let me run the program. So now as you see, although we only passed 10, it does not result in an error because the first value went into our first argument, a holds 10. And since b has a default value, it's 0 and the sum is 10. Now what if the one who's writing the program does not know how many inputs the user could give, or the user could give variable number of inputs to the function? Now suppose I want this function add to be able to find the sum of 2 numbers or 5 numbers or even 10 numbers. In that case, the argument that the add function would accept could be a list. And as you know, a list can hold any number of values. So now in my call, I can just pass n number of numbers and I'll just delete this line because now we don't have a, b, we have one list a and we want to find the sum of all the elements in this list a. So for this I can use a for loop to iterate through the list. So for I in a and total equal to total plus I, and total needs to have an initial value, so total equal to 0. And let me run this program now. So the sum is 110. So what happens here is we are passing 4 numbers. Now even if I want to pass just one number, that would also be completely acceptable by this function. All these numbers are put into a list and a list can have variable number of values. Now we are using a for loop to iterate through this list and we keep adding each number to our variable total and finally we print out total. So if you are unaware of how many values a function can accept, or you want to provide the function the capability of being able to access variable number of values, you can go for a list. We now move back to a previous version of our program where we are accepting AB, just adding AB and displaying it, and we are passing our values to the add function through our variables x and y. Now we'll make certain modifications here. So x holds 10, y holds 20. We are passing x and y to our function add. Now in add, what if I change the value of a and b? So I say a equal to 2 and b equal to 3. And then I'll also put a print statement here to print out the sum of x and y. Let me run this program now. So the first line of our output, that is the sum is 5, comes from our function add. And add has changed the value of a to 2, b to 3. But now when we are printing the sum outside our function add, it seems like our variables are still holding 10 and 20 and not 2 and 3. That means that the change in the value was reflected on our variables a and b within the function, but then that did not affect our variables x and y. So although we are passing the value of x and y to a function add, and a is holding the value of x initially and b is holding the value of y initially, are a and x essentially different? That is, does a hold a different memory space and x hold a different memory space? So let's find this out. Let's print out their addresses. So here, after we created x and y, let's print out the address of x and y. Then within our function, before we actually change the values of a and b, let's print out the addresses of a and b. And after we change the values, let's again print out the address. I'm running the program. So when you look at the IDs here, our first line of output, which is the ID for x and y, comes from here. Our second IDs come from this line here. And our third line of IDs comes from here. So our first line prints out the ID of x and y, which is exactly the same as our ID for a and b within the function. But then again, after our values of a and b are changed, the ID differs. So the ID here printed out in this line is different from the ID printed out in this line. So what this means is that x and y is actually passed to a and b. A and b and x and y are holding the same memory location. But the minute you change the value of a and b, the location also changes. So this kind of a passing from the call to the definition is called call by reference. So call by reference is when you're actually passing the object and not just a pointer to the object. So you're not passing the value of x and y, you're passing x and y to ab, which is why the ID here, that is the ID of x and y, is exactly the same as the ID of a and b. But once you change the value within the function, this is not reflected back in x. What Python does, it creates two new objects a and b, and the values are then put into these. Now we know that integers, strings and most other things in Python are immutable. So this might be why we have new objects being created every time we are trying to change their values. So what if we pass something that is mutable and try to make a change to this? As we know, lists are mutable. So now let's pass a list to our function and try to change the value in the list within our function and see if this is reflected back on the original list. So I'll just delete all of this. Although we won't be using the function to add anything right now, let's leave the name of the function at add. Now I'm passing lst list to my function add, and then I say lst of 2 equal to 0. And outside my function, I'll first create my LST. So that is 0, 1, 2 are my three values. Then I'll call add and I'll pass LST to it. Since we have no print statement, there's no output. So I'll have a print statement here, LST. And I'll also have a print statement before the call. So again, print LST, run the program. So as you see here, the first time we created our list, the values we gave for it are 0, 1, 2. So this is what's printed in this line here. Then we made a call to our add function. And in our add function, we changed the value of the element in the second index position or the third element of the list. We changed that to 0. And when we printed the value of LST even outside our function, this change was reflected in our original list. So it printed 0, 1, 0 and not 0, 1, 2. So with this, we come to a conclusion that with integers, we were creating new objects every time we wanted to change the value because integers are immutable. But with lists, since they are mutable, the changes are reflected back in the original object. So we are back to our basic program of the add function accepting two values a and b, finding their total and printing it out. Now what if we don't want total to be printed within the add function? So the add function's like, sure, I'll do the operations, but I do not want to give the output right here. So in this case, what we want, so the add function should be able to somehow send the value of total back to this line of call, and then we can print out the value of total. So first of all, add will not print the value of total anymore. Add will instead return the value of total to its call. So for this, we use the keyword return followed by the value that it's going to return, which is total in our case. And the line where we are making the call, this is the same line where the value will be returned. So now we need a variable here which will hold the returned value. So let me say sum, which is our variable. So result is a variable which will hold the return value of our function add. And then over here we can print out result. Let's run this code and that worked perfectly fine. So I'll explain this flow once again. Execution starts from this line here. The result equal to add 10, 20. First add of 10, 20 is called. So the add function is called a holds 10, b holds 20. And the total is calculated. Then this function returns this value total to the calling line. So this is our call line and we have a variable here result which will hold the returned value. Then we use this variable, we just print out the value. We'll cover what objects and classes in Python are. So previously we saw that Python is an object-oriented programming language. So what this means is that Python is completely focused around the presence of an object. And this is why we will stress more today on what this object actually means and what classes are in relation to objects. So let's begin. First we look at what an object is. So in the real world, everything tangible is an object. The table, the chair, your mobile phone, your laptop, even you are an object. And in the similar manner, in Python, since you're focusing so much on an object and programming around object, so every instance in Python is an object. Now, if that is what an object is, what is a class? A class is a blueprint of similar objects. So you'll have multiple objects in programming often, and all these objects have some similar features. So a class basically holds all these objects together and gives them a common definition. Now let's better understand this through an example. So here we are considering person as a class. Now if person's a class, every person has certain features, that is name, gender, age. Irrespective of who the person is, the person has to have these features. So this is something common shared by all the people. Now a person also has a behavior, and behavior basically means the functions a person is entitled to perform. So obviously there are a number of things that a person can do, but in this particular case we look at just two of them, which is talk and vote. Definitely there are some exceptions which we'll not dwell into right now. So now that we saw what features and what behavior are and how person, which is a class, describes these things, let's look at what an object would look like under this class person. So here we have two objects of the class person. Our first object, which is on your left hand side, has the features name, gender, age, and the behavior talk and vote. Now every object has to have these features because these are what's defined under the class person. And in a similar manner, the object that's defined to your right also have the same features and the same behaviors. Now what is it that makes these two objects two separate entities then? It's the value of the features. So our features, name, gender, age, in either case has a different value. For example, our first object has the name Sam. Our second object has the name Mia. Gender is male, and for our second object, gender is female. Age is also a different value for both our objects. Now they could have the same value, that is there could be some common features, but if all of them have the same value, that wouldn't make sense. They wouldn't make them two separate objects. So to summarize this, person is a class and the class defines the features name, gender and age. It defines behaviors, talk and vote. And then we defined two separate objects and gave value to the features in these objects. Now let's begin to code this example. So I'll move on to PyCharm. First thing first, let's create our class. So our class is created using the keyword class and then put down the name of your class, which in our case is person, followed by colon and enter. So your class is created. Now once that your class is created, the next thing we need to focus on are the features that this class defines. So the person class defines the features name, age and gender. Now in our previous video on oops, we saw that the features or the members of a class are defined using a constructor usually. So let's create our constructor, which is def init. And once you click on init, the self parameter automatically appears Self basically refers to the object that you're passing to this constructor or the object that is being created when the constructor is called. Now we'll give value to our three features. So our features are name, and that will have the value, say Sam, gender, male, and age 22. Now one thing that we're missing out here is that we need to remember that name, gender, age, all these are features of the class. That means these features are strictly tied to an object. That would be the object that's created when this init function is called for that particular time. So the reference to that object would be stored in self. Therefore, we won't just write name equal to Sam, but instead self.name equal to Sam. And in a similar manner, self.gender and self.age. So we have defined our features of the class person and also given it value. Now next thing is we have to define the behaviors. So behaviors are implemented through functions, or we can say methods. So methods are basically functions, but the functions which are called through an object or tied to an object are called methods. So let's define our methods. Our first behavior is the talk behavior. So if the talk method is called, we just want to print out hi, I am, and the value of the name attribute of the object that's calling talk. Now our next behavior to be implemented is the vote behavior. So for that we'll create a method vote, and here we'll put in a condition. So if the age of the person is less than 18, the person's not eligible to vote. So we'll print this out, and if the person is above 18, then we'll print out that the person is eligible to vote. So if self.age is less than equal to 18, I am not eligible to vote. Actually less than 18. If the person is 18, they are eligible to vote. Else print I am eligible to vote. So the two behaviors of the class person are implemented through methods now. Now all that's left for us to do is to create the actual object. So how do you create the object? If my object name is obj, I'll write obj equal to and then put in the type of the object. And the type of our object is of course the class. Now here's something that you need to understand. Everything that you create in Python is actually an object. So I'll explain this a little more in my console. So if I have a variable, say a, and I give this variable the value 100. We know that 100 is an integer type value. Therefore, that makes a an integer type variable. But then if I check the type of this variable, it shows class int. That means the type of a is the integer class, which makes a an object. In the similar manner, if I have another value to a, say simply learn, and now if I check the type of a, we'll see that a is now an object of class string. Str is basically the short form of string. Therefore, everything in Python is an object of some class, and that is how our object here obj is an object of the type person, where person is our class. So now that we have created an object, during this creation of the object, our constructor will be called and the features of this object will be given some value. Now we can use this object to call its behaviors. So this can be done either in this manner. So you put in person, which is the type of our object, dot the method, and within the brackets as a parameter, you can pass the object. In the similar manner, we'll also call our behavior vote and again pass obj within it. Now let's run this code. Just pull up my console here. Run the program. And as you can see here, so we created an object and the object got its values as mentioned in the constructor that is in it. And then we called the talk behavior or the talk method using our object obj. And this printed our first line, which is hi, I am Sam. And then we called the vote behavior. And in the vote behavior, the age of our object was checked. Since our object's age was greater than 18, it says I'm eligible to vote. Now these two lines where we are calling our methods can be done in a different way. Instead of calling it with the type of our object and then passing our object, we can directly call it with our object. So we can have it in this way, obj.talkOf, and over here obj.voteOf. So we must remember that in this particular case, where we are creating classes and objects and have this kind of a structure, all these methods are actually tied to the object, which is why we cannot just say talkOf. We need an object to call it, or at least pass an object to this method. Let's run the code now. So it's the exact same result, works just fine. Now in this case, we just created one object and the values for this object were predetermined and just put in our constructor. Now what if we want to create two separate objects and the values for these objects vary? So in this case, so to demonstrate this, we'll create two objects just like in our example previously. We'll have our first object, which is obj1. Now both these objects will be of course of the type person, which is our class. So put that there. Now every time the object is created, automatically our init method is called. So if our object needs to have separate values, what we can do is instead of putting in predetermined values here, we can pass the values for the features of the object in the brackets. So if I want my name to be Sam, I pass Sam, my gender, and the age. So these are the three values for the three features that this object has, which we'll pass into the constructor or the init method. Now in the init method, we need to be able to accept these values. So other than self, we'll have one variable which will store the value of the name when it's passed from here. We'll store it in variable n for name, and the gender we'll store it in variable g, age we'll store in variable a. So what happens here is basically these values that you pass within the parentheses when you're creating your object are sent to your init method. Now in the init method, we are putting down these three variables to accept the values. So these three variables store these three values. So Sam goes to n, male goes to g, and 22 goes into a. Now instead of putting in the strings here, self.name can be equal to n. So the value which n got is now put into cell.name. And the value which g received is put into cell.gender. And the value which a received will be put into self.age. So that way we created our object and provided a way in which we can actually have unique values for each object. So now if we have another object, say obj2, which is also of the type person, we can put in different values into these parentheses. So say our second object's name is Jessie. She's female and 16 years old. So now these values will go into these variables and will be assigned to these features. So for obj1, if I say obj1.name, the name would be Sam. If I say obj2.name, it would result in Jessie. We'll see that now. Let me just print that out. obj1.name and obj2.name. So as you see, although our feature is the same, we are printing the feature name in both the cases. The object to which this feature is tied is different. So the first time it's printing name related to object 1 and the second time it's printing the name related to object 2. Now this is not what we want to show here. Here what we want to do is after creating our two objects, we'll call the methods using these objects. So obj1.talkOf and obj1.voteOf. Now we'll call the same two methods using obj2. So obj2.talkOf and obj2.voteOf. Run the program and here's our output. So what happened here is obj1 was created and the three features which are name, gender and age were given the respective values for obj1, and in the similar manner obj2 also received the values for its various features. Now we used obj1 to call our two methods talk and vote. At talk, all we did is print our name of the object. So the first time when we called with obj1, it printed hi, I am Sam, because Sam was the name related to our first object. And then we call the vote method using obj1 itself. So our first object's age was 22, which means it's eligible to vote, and that is what's printed here. I am eligible to vote. Then we call the same two methods using obj2 and got different results. So obj2's name was printed here, which is Jessie, and then Jessie is underage, that is she is 16. So it printed out I'm not eligible to vote when obj2.vote was called. So that is the basic crux of what objects and classes are.
In this, we're going to cover a basic understanding of object-oriented programming, and we'll be specifically working in the Python interface, or the Python code. Oops, the basic concept, is not the accident you just had or the mistake you just knocked your coffee cup over off your desk, but it actually stands for object-oriented programming. And whether you're working in Python, which we'll be doing today, or in any scripting language, almost all of them rely on object-oriented programming as their basis. Programming paradigm that focuses on objects. So everything is an object in the coding. Every instance in Python is an object. And again, this is true for any of the main programming languages. If you're working in Java or Scala or any of these, you're going to be looking at object-oriented programming. It just makes a lot of sense and really is one of the cornerstones of today's programming. And when we talk about object in programming, an object has two different things. It has two different things: attributes, which is data describing the object, and behavior, methods on the attributes. So the first one is your actual data, and the second is what are you doing to that data. And if you're a car lover, we're going to use cars as an example. This is kind of easy to see how that might fit into the different objects. And so we're going to start with a BMW, for example. That's an object. And with the BMW, you might have like the year of the manufacturer, maximum speed. Those would be attributes of that car. And then you have the behavior. These are methods on the attributes. For example, you might display the speed or change the speed. So even though you have a maximum speed, you might have current speed also, which changes depending on what you want it to do. Step on the accelerator, go faster. Step on the brakes, go slower. And the primary terminology in programming is usually class. And that's definitely true in Python. So class is a collection of similar objects. And in this example, we have cars are class. So you might have trucks, bicycles, and airplanes. But in cars, we have some very specific things. Cars have four wheels that are on the ground, maybe a spare hanging down, headlights, steering wheel, things you would expect in a car. Doors to get in, so it's all inside. And in here we actually have a number in the collection. We have our BMW, our Ford, our Audi. You can guess the guys in the back like the BMW the best. I don't blame them. And so we work with classes or a collection of items. Today I'm going to use the user interface PyCharm. It's one of the very popular Python editor. I myself have never used it, so this is a new experience for me. It's pleasantly fun to use and easy to set up. You can go to jetbrains.com. That's the people behind it. So www.jetbrains.com/PyCharm/. And once you're on the PyCharm, if you go under downloads, you'll have two options. Let me just hit the download now button. It'll take you to the two options. One is the professional, which you would pay for, which allows integration between teams and company setup, and has a bunch of extra cool tools that you need for a business. And then there's a community version, which is the lighter weight one for the purposes of this demo and most of the work you do. The community one's probably just fine. You can download it. It's open source and it's free. I don't know about you, but I like open source and free on a lot of my stuff. And I've already opened up a project file, but you can create a new project file up here. Put a note down in the YouTube and they can send you some of this code, or go visit Simplilearn. They'll send you the code itself if you need it. There's a lot of different, like I said, functionality in here. We're both mostly going to be underneath just run the demo. In this case, I'm doing oops Simplilearn, so we'll just be running what I'm working in here. Let's go ahead and start with creating a class in Python. And you simply just tell it it's a class. So the class means this is going to be our Python template, whatever we are working on. And we'll call this car. And this is interesting because class itself, let me just highlight that. So when I put up class here, that is a Python object, and then I'm using that to build car, my class, specifically on here. And let me go ahead and just change that font. I have it pretty large already in my editor. Let's go back down here to editor. Font, and I put it up all the way to 26. I think we can get it by with 30 so you can really see it. Hopefully that's going to be big enough on there. And so once we have our class, we want it to do something. And so in a class, when you put the words def, That stands for definition. Whatever that's called, that is a function. It's going to actually do something on there. And you'll see what I like about this is nice. With PyCharm, it automatically puts self in there. Why? Because self refers to whatever the object is. Now, it doesn't refer to the template class car. It refers to the instance of that. And I'll show you in a minute what that exactly means. But in this case, we're going to do something simple. We're just going to have it print. And you can see it automatically indents it. So Python, if you remember, or if you're new to Python, is based on indentations. You have to indent. So everything under this indent is part of the def. Everything under class that's indented is part of the class. And so we're just going to look down at our speedometer, and we're going to print 155 miles per hour. Maybe it's on the Autobahn in Europe, I don't know, racetrack. Not very often you go 155 miles an hour in a car, at least not in my experience. Maybe in the future we have auto cars that do hundreds of miles per hour and shoot down the freeways. And let's go ahead and create an instance of the class, and we'll simply do BMW equals car. And we'll put brackets on there. And let's also do, let's do a Ford. Ford equals car. So if you remember, car is like a template. It's still an object. So I have BMW equals car, and I have Ford equals car. These are two separate instances. So they're copying, or they're actually putting a pointer to car. So everything under car is part of BMW. And the same thing with Ford. And we can do something like this. We can go car dot get speed, and let's put in the BMW there. Or we could also do car dot get speed Ford. Given the choice, I think I'd go with the BMW. And there's another way you can do this. We can also do BMW dot get, because remember it points back to the original template, so all the functionality is in the original template. And then we could also do Ford dot get speed. These are a little bit more common, more than you'll see the top part. But let's go ahead and run this. And if we go under run, we find out that Alt-Shift-F10, you can use the hotkeys, which I'll probably start doing. And I just simply hit, make sure I highlight the one I'm working on, and it runs it down here. And so you can see right here we have 155 miles per hour printed out by the BMW, 155 miles out printed by the Ford, car get speed, and then I did it in a different format, BMW.getSpeed and Ford.getSpeed. The thing to notice is the term self. That is a Python term, which means that when we create an instance, whatever comes in here is what's being processed. And so if I call the class or the template directly, in this case I did car get speed, I have to include what that self is. In this case it's a BMW. Or if I'm calling it from the instance BMW, because it includes the car class, it knows that get speed, and it knows automatically that this is self. And that's where the term self comes in. So that's important to note in there. In Python, it's one of the more Pythonic kind of solutions, is that when you see the term self, that refers to that instance that you created. In this case, the BMW instance and the Ford instance. When you're setting up a class, there's a lot of things you can do in here. There is a key term init. What this means is that when I create the new instance, whatever happens in here is going to be set. This sets up your information. Let me show you how that works. And what we're going to do is we're going to pass year and speed in here. And this is really important, is I need to take self, that's going to be the new instance I created. In this example, it'll be our BMW and our Ford. And put a period here, and then year equals year. That's the variable that was passed. And we'll do the same thing with speed. Self.speed equals speed. So when we create this, we now have two different variables in here. And if you remember from our slide, an object has attributes, data describing the object, and a behavior, methods on the object. And so in our class or our template, we're going to initialize it with the year and the speed on here. But if we initialize it here, when we create the instance, we have to send that information so that it knows what the year is and what the speed is for the BMW and the Ford. And that means when we create this instance, let's go ahead and do 2018. Maybe this is the maximum speed that shows up on the speedometer, I don't know. But 2018, and we'll put it at 155 miles per hour. And then we'll take the Ford, a little bit older, runs a little slower. It's a 2016. And this will be the maximum speed. We'll do 140 miles per hour. That's the fastest it can go. And then, so now we've set up some data on our object. right here coming through, and so BMW now has a year and a speed, and so does Ford. And when we get speed, let's go ahead and change this. And in fact, I'm going to do, let's just get rid of this middle part, because I tend to do the standard BMW.getSpeed. And we'll call this maximum speed. Maximum speed is, and then we'll just put down self speed. So that's our variable. So that's whatever the instance is. So self speed is going to refer to our BMW or our Ford. And if we go ahead and run this, and that was, we can go up here to run and Alt-Shift F10. I'm just going to do Alt-Shift F10. It's already set to the tab I'm on. Hit Enter. And we come down here and you can see, had an error there. This is a double underline for the init. The code that they sent me had just a single, and I forgot to double check that. So we have a double underline init. It comes in year and speed. The BMW has 2018 with a maximum speed of 155, and when we print that out, BMW get speed, you'll see it right here, the maximum speed is 155, and then it does it for the Ford. Maximum speed is 140, and then we're done processing it. So we stored some data in here. We stored the year, we stored the speed, and then we've had a process on that data, and that is to go ahead and just print it out. Print out the self.speed. And let's go ahead and briefly look at encapsulation. Def set speed self speed. So we're going to send it a new speed value to set the speed. And from here we'll go ahead and do self.speed equals speed. And we'll just work with the BMW on this one. Let's take the Ford out of there for a moment. And we have our Ford get speed. And then we're going to set the speed. And the new speed is going to be, let's make it 143. Just an odd number so it's easy to see. And then we'll go ahead and do BMW.getSpeed. And when we go ahead and run this, I'll do the Alt-Shift F10 and run it. As you can see here, it comes out and says 155, because that's what the speed was when we first entered it. And then we went ahead and changed it. BMW.setSpeed, and is now 143. So you can see here how we can alter the information in our template. And if we remember, we had the Ford is completely separate from this. So if we still had Ford down here equals car 2016, 140. If we still had that down here, this 143 isn't going to affect the Ford at all, because this Ford instance is separate from the BMW. So if I do Ford.getSpeed, and we do an Alt-Shift F10 to run it, there we go. Here's our Ford, 140. So it hasn't changed even though we set the speed on the BMW to 143. The first thing we want to look at is inheritance. And so inheritance is a mechanism for a new class to use the features of another class. And if you've ever done like word processing, you might use a template. From that template, you can have all kinds of stuff you put into the template, and you can save it in different instances depending on what you're doing. And then those particular instances you saved could be used as a template for your next thing. I use that all the time. When I was in sales, I do some sales on the side as part of my job, working with them to support them and build the software for them. We'd put together a document, and then we take that document, and that'd become the template for the next 3 documents that are very similar. This is the same way. You have a class, and from that class we can inherit everything from there and then make changes on it. And then we're going to go ahead and cover, let's do this. Ford BMW, just close that up. Take this out of here for now. Okay, let's go ahead and do inheritance. That's where we're going to take the class car, and we're going to bring all these features from class car into a new template or a new class. And let's start with a class sedan. And the sedan is going to inherit from car. So it's going to bring car in, and now we have a sedan coming down. Once we create the sedan, this is now a child class to car coming down. And under this class, I'll just go ahead and we'll just type in a def accelerate. Of course, self. And on here, we're just going to have it print. And let's have it do 150. That seems like very high. Let's go 133, just because. I don't know why I like the 133. Let's change it to 137. There we go. And then let's do another one here. We'll do this class SUV, and it also is going to inherit from car. And this too is a child class of car, so we'll just put a label there so we can remember that. And we'll also give it an accelerate. And when we do an accelerate, keep the self, and we'll print, let's see, this year, whatever production is 180. I don't know why. That seems awfully high for an SUV versus a sedan. Let's do 127. The SUV goes a little bit slower than the sedan. There we go. So let's go ahead and hit enter on there. And let's take a look at what we got going here. I have my BMW. I have my Ford. And let's add a Honda, and we're going to make it equal to the sedan. And just for fun, let's add one more thing. Def, open, trunk, self, and we'll hit print, trunk has been opened. There we go. So let's take a look and see what we got going here. I've created my Honda, and if you remember up above we have our BMW, and I'll just do just the BMW, get speed, and then I want to do the Honda, get speed. And when we run this, we can see our BMW is 155, and our maximum speed on our Honda is 150, because that's what we set. Now remember, this inherited it from cars, so this init is now part of the sedan. The open trunk, if we do this, if I go the other way around, let's say, let's do this. Let's do the Honda open trunk, and then we'll do, just to throw an error here. This is going to give us an error. It doesn't even auto type it for me. So we'll do Alt Shift F10 and run it. And you can see down here is that we had our BMW get speed. Okay, there's our 155. We had our Honda get speed. We had our Honda open the trunk. And because our car, when we go up here to car, does not have open trunk, the BMW does not have that definition. So it gives us an error. So we can't do that unless we add that to the top as part of a car. It just turns out though that, let me just take the BMW out. For whatever reason, this BMW doesn't have a trunk. I think they all have trunks, but that's okay. For this example, we'll just leave it like that. So you can see right here we've inherited, and then we've gone ahead and added new features to our new class. So this child class of sedan has come in here. Now it has both accelerate, open trunk. The SUV, which we're going to look at in just a second, also has open trunk. So we've had a lot of functionality. We have our original car template, so whatever's set up here comes down here. And then we've added both accelerate. Let me just do that right here. Our Honda, we can accelerate the Honda. And if we run that, you can see the Honda has their acceleration come in and prints out. In this case, 137 down here. That's why I like to mark it with a weird number like 137, so you can tell the difference where we're going. So we have our accelerate. So we've added features into our sedan. Encapsulation is an important feature, preventing data from direct access. This is what we call encapsulation. We'll discuss that more later on, but what it means in this particular case is that when you create a class from another class, you can't alter the original template. The child class can make all its own changes to that class and do all kinds of things, but it can't make any direct changes to the parent. Let's go ahead and take a look at encapsulation in the code itself so we can have a better idea of what we're talking about. And so we have our class car, and we have our definitions. Here's our init. This is from, if you remember from the last slide, we had our init. Maybe we add a couple more functions to it or modules to it, and we have get speed and set speed. All of this under class car is encapsulated. What that means is that if I create an instance of it, in this case I'm going to create a BMW. Wouldn't that be nice if I can just whip out a BMW and make a BMW? When we create our instance BMW, it does not change the class car. This, whatever we do to this instance, does not make changes to our class. And the same thing with the Ford. The BMW does a get speed. It might do something here in the definitions under the class, but the initial class, if I create another car, let's say we take our BMW and we set the speed for 155 like we did here, and we create a Ford, whatever I do with the Ford does not change the class car. And if I create, like we did before with our inheritance, a subclass, that's not going to change the class car. That's what they call encapsulate. It bundles things together, and it really is central to OOPS, object-oriented programming. Is we're basically bundling things together, and then we keep them in a nice, safe bundle. And anything we do from that, we either point to it and say, hey, let's use this definition, or we make a copy of it. So we kind of do a combination of there and say, okay, here's our new inheritance. But you can see right here, this is encapsulation. And again, that's like central to OOPS. This is how OOPS was originally discovered, created, and founded, is when they realized, hey, why don't we just bundle things together instead of rewriting the code over and over and over. And then polymorphism. We talked about encapsulation in classes just recently. Like I said, we'll go in this and when we open up the code. Polymorphism is we take the feature in the code and then we can alter that feature. So we can use the same function in multiple ways. That's a lot of fun, a lot of power in that. Let's go ahead and take our polymorphism and take a look at it, what's going on in the actual code when we're writing our Python code. So here we have our parent class, car, and we switch colors. Here we have a sedan, where we inherited the car, and an SUV, also an inheritance. And when we look at this, we have up here our init. So let me just so we have our definition, we're initializing it. The first class, we've added in accelerate. So what that means is with our acceleration, that's not part of the initial car class right now until we add it in. So we have our definition accelerate, which print 150 miles per hour. So all sedans have a print of 150 when you do accelerate. All other cars don't have anything going on in them right now. And then with SUV, we're going to define the accelerate differently. So we have the accelerate down here with self print 180. So we have two different polymorphs going on here. We have one polymorph going on in this example. We've added accelerate to both of these classes. And so it doesn't matter which one I accelerate, it's going to do something. And so if we create, in this case, we're going to create an object down here, an instance of it. Do this in pink. Here's our instances. Oop, that's a little light. Let's do something a little darker than that one. There we go. So we have our instances, and we're going to create one object, which is a sedan, a Camry, and one object, which is an SUV Scorpio. And then we can just go through the objects. We can actually just loop through the objects, one object at a time. And if we do print object name and end, we have our object name. So it's going to print the name. In this case, it'll print Camry and it'll print Scorpio. And then we have object accelerate. And for the sedan, since that's our Camry, it's going to print the 150. And for the SUV, it's going to print 180 for the Scorpio. And so by doing this, we polymorph the same definition to do two different things depending on what our child class is. So we can polymorph all kinds of things, and we'll actually look at a couple more objects in there when you go through the full code later on. There's a couple more examples in this. But this is a polymorphism coming down, and you can see how we're able to leverage the same name for the definition to do different things depending on what our object is.
Look into threading in Python. So before we jump into what threading is, let's have a look at what a process is, because that is a core concept that you need to understand before you understand threads. So a process is an executable instance of a computer program. That means anything that is running on your computer is actually a process. So a WordPad that's opened, a mail that you're sending, anything that's running, that's working could be a process. Now that we know what a process is, let's look at what a thread is. Now a thread exists within the process. So the definition of a thread is that it's a sequence of instructions in a program that can be executed independently of the remaining program. So if we write a large program, of course there are many small tasks that the program performs. Now each of these small tasks can be a thread as long as their execution is independent of the execution of the other tasks. But then why do we need threads? So consider your system. Now these days we all use multi-core processors. That is, we have multiple cores in our system. Now the point of threading is to make the maximum utilization of these cores. So if one program would run on a single thread, that means it would utilize just that one CPU or that one core. But if we can divide a program into multiple threads and have each of these threads use a different CPU, our program would execute much faster and it would be way more efficient. So this is why we use threads. So now let's look at threading in Python through some demos. So first let's look at the most basic and the simplest way of creating a thread. I have a function here, show, and this function will just print this is a child thread, as we are going to have the child thread execute this function. So first thing, we need to create our thread. Now before we create the thread, let's import the threading package. So we have included everything from the threading package. Now we'll use the thread of method to create our thread, which will be called T. And to this method threadof, we'll pass the target of our thread. That is basically the task that our thread will be performing, which in this particular case is the showoff function. So you say target. So we set target's value equal to show, our function show. And now outside here, we'll just print this is the parent thread. So I'll just explain in general how a thread works. Now the minute you write a program and you start running it, there's a thread created. Now this default thread that is created is called the parent thread. So the execution of your program is performed on the parent thread unless you explicitly create a separate thread. So if we had not created this thread here, our entire program would be run on the main thread like every other program is. But now that we created a thread here, this thread, that is T, will run only this show of function because that is the target of this particular thread, and everything else in the program will be run on the parent thread, which is why we have this print statement here saying this is the parent thread, because this print statement is not within the show of function and hence it will be run by the parent thread. Now so far we have only created the thread though. So we need to start this thread, and to start a thread, use the thread name followed by dot and you call the start of method. So the start of method belongs to the thread class, and as you have probably noticed already, our thread here T is an object of the thread class. So once you say T.start, the target function of this particular thread is run, which in our case is show. Now I'll run this program, pull this up here. And as you can see, first we have our child thread executed and then we have the parent thread executed. Now let's look at the second way that you can create a thread, which is by importing the thread class. So you still need your threading package, and I'll create a class, myThread, which is a user-defined class. So I'll be defining this class, and this class will now be a subchild of the thread class. Now the thread class already exists. It's a predefined class, and we're extending this thread class into our class myThread class. What this does is all the properties of the thread class is now present within our myThread class. Now within the myThread class, I'll be creating a function def run, within which I'll just print this is a child class, say 5 times using the for loop. And outside here, I'll create my thread. So now that our class myThread has extended the thread class, we can create an object for myThread, and that by itself would be a thread. So T is my object of myThread, which would also be the thread. Now if you notice here, I'm not passing any target. So this is because when you don't pass any target, by default, your thread will call the run function. So it'll come here and it'll execute this function. So the thread class has a blueprint of the run function, and every thread that is created as an object of the thread class is designed to call this run function by default. So what we do here in our myThread class is we redefine this run function for our purpose. Now of course you need to start your thread, and outside here, which is the part that will be executed by my main thread, I'll just print out this is the main thread, and let's run this code. So we'll just add the new lines. So here there's child class, main thread, main thread, main thread, so on, and then we are back to child class. So if you're wondering why this kind of a mix-up is happening, I'll explain that to you. Now our entire program was initially planned to be run on the main thread, but we created a child thread here, which is T, and made the child thread take care of the execution of this def run, of this function run. Now while our thread, our child thread T, was executing this for loop, and between that gap of printing this out and moving to the next iteration, our main thread was completely idle. So the main thread took up this time to start printing out this for loop, and that is why you have this mix up of child class and the main thread printouts. And now we'll have a look at the third way you can create a thread. This time we'll not be extending the thread class. So I'll have a class, say demo, within which I'll have a function show. And within this function, I'll print out this is the child thread 5 times using the for loop. Now outside here, I'll create an object of my class demo. And now I'll create a thread, which is basically an object of the thread class. And to this, I'll pass the target just like we did previously. But this time, because a function exists within a class, we'll refer to the function with an object. So we have a reference now. And once that's done, back to starting our thread. And outside here, I'll print out this is the parent thread 5 times using the for loop. Let me run this code now. So you can see the output here. We have, this is a child thread printed 5 times and then 5 times of the parent thread. Now Python can be quite deceiving. So now that we looked at what thread is and how threading works in Python exactly, we can move on to multi-threading. So multi-threading is a model where you have multiple threads within a process and all these threads can execute independent of one another, but they are also sharing all the resources of the process. So by the resources of the process, we could mean the various data that the process holds, the files or the stacks and so on.